Hi guys, how is it going? Today I'm going to present Git Feature Flow, a Git for workflow that I found very interesting. I want to present to you. So the workflows that we use with Git are recipes for how to use release management system so that developers and DevOps teams work efficiently. So these are recommendations I need to stress because they are not set in stone. They can be modified according to the needs of the team or project. There is also another perspective that you can deduce the team's character and culture by understanding the workflows they use. You can understand how many members they have, how they adapt to a request from the customer. So that is also an important sign of the team, which workflow they use. So workflows with Git and with other version systems, we have many of them. So this is what I could find when I was researching about those. So we have some very simple ones like this on the left side, that is only one branch, that is called trunk. We have also this one that is very simple, that is GitHub Flow. And we have more complex ones, with being the most complex one of these, the Git Flow, that has many environments, which is shown in different colors. Today I will show what I found about them and also show what I found about this one, that is Git Flow, that I am mainly interested in describing to you. So this is a situation I find frequently in the teams I work with. It happens from the customer side that they prioritize getting what's working into production as soon as possible. So they want to have the features that work as soon as possible into production. It happens sometimes that the customers want to have a deployment that is before the final deployment date, but they want something that happens previous. We are in the agile environment, so they usually ask us to have multiple sprints and to deliver many times. From the side of the developers, it happens that they receive a request for additional features or changes, but those additional features or changes happen near the release date. So we need some way to balance these situations and to have something that we can deploy at any time. So thinking on that, I analyzed the workflows that are usually used and also others that are more theoretical. First of all, I thought about what about using a single branch. A single branch looks very simple, right? Because it's an easy to understand graphic. If we work with a single branch, the first thing I thought is that each developer would upload the code and it would have to magically match with the latest version uploaded to the main branch. So no conflicts would happen for this to work perfectly. But of course, that is ideal, that is perfect. There are requirements that have to be accomplished to make this dream workflow come true. And to say it in a nutshell is that we need a super infrastructure. What do I mean with a super infrastructure? I resume that in these 3 points. So first, we need super robust automatic testing that ensures each new commit works well in production. We don't want to put anything that is not working here because we have only one branch, so everything that goes here needs to work, and we need super robust automatic testing that checks that what we are pushing is actually working. We also need repository maintainers that are heroes. Those heroes will resolve conflicts and perform code reviews quickly, so they will take the best decision about conflicts as soon as possible. Finally, we need an effective rollback mechanism that allows errors to be resolved during the development and return to a previous version in case something strange happens. So this seems theoretical, but I was also looking about who is using that. It turns out that tech giants like Google, Meta, Netflix, etc. use trunk-based development to maintain a structure as close to a single branch as possible. That is what they call it. They call it trunk-based development. But it's not exactly a all-in-one branch, or could it be? So when I was doing the research, I found this book that is called Trunk-Based Development, that I found all the contents on internet, and from there I found this concept of the monorepo. The monorepo is a specific implementation of trunk-based development, which is an organization that places the source code for all applications, services, etc. in a single trunk, which is the main branch. And the most well-known monorepo is Google. But not everybody works again with trunk-based development, because this is a recipe, this is not written in stone, so there could be variations. And it's common to find projects under the name trunk-based development that use very short feature branches that last a few hours and then emerge. So we have something more like this, where we merge to the main. Nevertheless, well, taking apart that small detail whether or not there are feature branches, we should consider that we always need that superb infrastructure to keep the code always available in production. So that is the main problem. How would you develop that infrastructure? That could be done in big companies, as I mentioned, but if we don't have that capacity, we don't have that time, we should need to check other workflows. So another workflow that looks simple is GitHub Flow. GitHub Flow has one main branch and has long-running feature branches. So this is similar to trunk-based development because the topology is easy to understand, and also trunk-based development could have feature branches but with a small duration. So I mentioned here that that duration is the main difference, because in Git Flow those feature branches could last days or weeks. Also, there is this important thing to notice. So here we have a representation of how branches appear in the code. So this is theoretical, but there is also this representation that is more accurate. Why do I say so? It happens that when we have branches that have long duration, that have long life, we make multiple commits to each branch. And when we have separate branches and we make commits on each of them, there could happen conflicts. And the longer they live, it's more difficult to unite them again when merging. So this is a representation that shows that more conflicts could happen if they are separated, they are more separate. The existence of those long-lived branches increase the workload of QA team. This means that moving to latest features to production is not agile. I say this because if we have branches that are long-lived, merging them again to main could be troublesome sometimes, so this will be a bigger overhead to QA team. So achieving these last arrows could be the bottleneck of this workflow. There are also other workflows that were checked in this research. So I checked about GitLab Flow, which is more complicated, and it complicates the workflow to have multiple versions of software to support. For example, this could be used for the development of 2 versions of a CAD software that are still being patched, but it doesn't have a flexible deployment date. As you can see, we don't have the possibility of releasing only what we have working at this time, for example, because we have to merge what we have working to each of the release branches. We have, for example, the release branch of this year, the release branch of the last year, and we keep patching those. And we have also this environment where we perform different tests. There's also Git Flow, which is an even more complicated workflow designed for software with fixed release dates. For example, operating systems like Ubuntu. It's difficult to decouple code that doesn't pass testing from the version that goes into production. Therefore, it doesn't allow for agile delivery. So as we can see, from the main branch we have a develop branch. From the develop branch we have the features. We merge the features again to develop, but then we have multiple choices that we can do. We can use this release branch because this is what we actually release. So we can use this, or we can merge again to main, or we can have hotfix. So the flow complicates a lot, and it's usually that we need someone who maintains this and use a good amount of time to keep this mess in a way that at least one person can understand. So this is difficult to use for an agile environment that where we need to deliver multiple times, and we need to deliver at times that we don't know that beforehand. This is better for projects that we know beforehand when we want to deploy it. So that is why I said that operating systems like Ubuntu are projects that where we can apply this. So going again to that situation I mentioned, that is from the customer point of view and the developer point of view. I was considering and balancing those point of views, and I realized that I was looking for a workflow that has these features. So I was looking for a workflow that allows me to adjust the product's delivery date. So it means that, for example, if we arrange that the final delivery date is, for example, 3 months after today, but it could happen that during the development the customer asks me to deploy whatever is working. So I want to be able to adapt to that sort of request. And also I want a workflow that allows me to deliver anything that is functional. So I want to deliver only things that are functional. So I don't want to release features that are not well tested, that I know that have some problems. I don't want to have those in my main code that is going to production. I only want functional code. So looking about that, I found two interesting cases that I received here. One is from Guru Navi, and a Japanese company that has a website that you use to search for restaurants, search for places for banquets or for wedding parties, etc. So they used Git Feature Flow, and also there was this article in Medium where I found a reference about a digital agency in Australia that used Git Feature Flow. So let's explain what is Git Feature Flow. But to do that, I will do a comparison with Git Flow. In this case, this is a very simplified representation of Git Flow. We have a master branch. From this master branch, we get the develop branch. From this develop branch, we get the features. We have a feature 1 that we make commits until we think the feature 1 is ready. When this is ready, we merge it to develop and we perform some tests. In this case, the X marks that the tests are not successful, that the test failed. Also, from that time we get a second feature, a feature number 2, that is developed in this place. I will mention that it's not important if feature 2 starts from this commit or starts from this commit. The result will be the same for this example. When we think that this feature is ready, we merge it to test, to develop. When we merge this, we make the test and the test passed. So now our chore is to correct feature 1. When we correct feature 1, we make it pass the test, and finally we can merge to master and we can deploy. But Git Flow will have this limitation. So this is a flow that has an important limitation. The commits in feature 1 branch have not passed the test yet. As you see, at first it didn't pass the test. So I don't want to include this code in my release. Okay, so this becomes a problem when you want to release at this point. As you can see, imagine that customer asks me, okay, so the final release date is this, but today I want that you release whatever is function. So At this point we cannot do that easily because we have code that has a good feature, that is feature 2, and a bad feature. We have all those two features mixed, and we want to have the good practice of not mixing good and bad code. So we need to separate that, we need to decouple that. That is an extra effort that could take a long time depending on what is the project you're doing. Sometimes this is not possible at all, or this very requires a lot of attention, a lot of time from the developers to achieve this goal. So there should be a better way to do this, right? So that better way to do that is Git Feature Flow. For this case, we use the same example and we change the flow to Git Feature Flow. So in this case we have a master branch. From master branch we get the develop branch where we make the tests, and we have feature branches, feature 1, feature 1 and feature 2. So feature 1, as we can see, we developed and we merged to develop branch and the test failed. Then feature 2, we made our commits and we merged to develop branch and it passed the test. At this time we have feature 1 not working, feature 2 working, but we use this fork structure. We merge feature 2 to main to master branch, and we are able to deliver, we are able to deploy at this date. That is not the final date, but is before, so we can have a preview of what our project is. Yes, as you can see, using this fork-like structure let us merge only whatever is working. Bad code is not merged to the main. So after that we can correct feature 1, make it pass the test, and then we can merge it to main. So this also, we should notice that this requires that features are decoupled. So we need features that are not dependent from one another. So that is also a task that a project leader should think before assigning roles here. So we need features that are not coupled, so that we can develop those independently. So this is a resume of the environments that we use in Git Feature Flow, because, well, in this example we used only 3, that is the master, the features, and this is called develop here, but this could also be called test. So we have 3, but there are projects that we have the master, the development that contains the features, we have the test environment, which we call development in this slide. So well, this could be this is the branch where we make a test. There is also sometimes a staging environment, which is for doing larger scale testing. So this could be used for larger projects, and because each feature branch is independent, which is what I was explaining, it's easy to respond to sudden deployments and release date changes that could happen when we have a customer that asked us to have something previous to the final deployment working. So as any workflow, this could have advantages and disadvantages. So this is how I pointed it out. So the advantages is that there is independent release of each feature. You can release each feature separately without depending on others. Okay, so you can always have something that is working ready to deploy. You have no need to create hotfixes branches. Feature branches are always created from the main branch, handling hotfixes in the same way. Okay, I mean with this that what we are doing here is always hotfixing, so there is not a different rule or procedure that you follow to do a hotfix, because it's mainly the same. There are also disadvantages, of course. You need to manage its feature until it goes into production. If a feature branch is forgotten, it may never be released. Therefore, keep track of each feature in task management software. Okay, so what I mean is that, for example, if we have 10 feature branches, we could forget of the existence of one of those, and we never merge that to the test or the master branches. So to avoid that, we could keep track of that using task management software, for example using issues in GitHub, GitLab, and additionally we can make scripts that generate pull and merge requests to the testing branch at the same time as the main branch to avoid oversights. What I mean with that? I mean that we could make some scripts that, for example, if we passed a unit testing, it generates automatically a merge request to the test branch, and if the test is passed here, another automatic merge request is generated to the master branch. This could be used to help new developers automate the process and avoid some errors that could happen for someone that is still not used to this workflow. There is also another disadvantage, that is about the conflicts that could happen with Git Feature Flow. If a feature is developed for a long time, I mean long-lived branches, without being integrated into the main branch, it can generate conflicts when merging. In these cases, coordination between feature branches is necessary. I mean with this that since we are merging features to one branch that is used to make the test, it could happen that there are conflicts between them when we do the merge, so we need to coordinate between the developers about how to handle those. And the good point is that if we found those conflicts, it happened early when we are making the test, and once we solve those, we have one idea of how to solve them when it happens on master. Finally, I found this example that is more elaborated using Git Feature Flow from the article for Medium, that I can review very fast with you, just in a way that you have a second example and you understand this better. So we have the article from Medium here, and here we have this example. That the company that developed this is a digital agency from Australia that is called Depend. So here we have 4 environments. As you can see, this that is called production. We have here our main branch, and from this main branch we have 2 feature branches that are yellow and that are violet, that are in this environment that is called features. We make our commits, and when it is ready, let's say that it passed a unit test, we merge it to this red branch that is used for testing. So we merge and deploy, and when that internal testing is passed, there is some notification. When that internal test is passed, we make a fork. As you can see, we have this is merged to here, and then the test is passed, then we merge to here. That is this staging where client makes a test. So this will take some time. Also, we are doing the same for this violet branch. We make the commits. When we think we are ready, we merge to test branch, and then we pass the internal testing. Test is passed, and then we use the fork-like structure, and we merge the violet feature to this staging branch. Well, this test is faster than the yellow one, so we have complete the client testing, and since we have this release date and we have one branch that was completed, we only need to merge that branch and to make a release. So the yellow branch is not included in our code for main. Also, it happens that sometimes there are code refactors or other changes that they do directly to main. That is what this example is saying, and when we do that, we use that fork-like structure to merge to all other branches, and then this can follow completing the yellow branch. And also the example shows how to work with other branch, which is this feature branch that is of green color. So this is a way that this Git Feature Flow is used. So now it's time for an example of using Git Feature Flow, so you can understand that even better. So I will make a dummy project to show how this works. I will use here my terminal with Temux that I use this to divide. Not sure if I will use all these divisions. I am also using this program that is Git Neuro, that I use to show how a Git repository is the history graphically. So first of all, I will make a new directory here that I will call it GFF example. So I will go to Git Feature Flow example, and I will init a Git repository. So I will use the command git init. I think I will use a bigger font. Okay, here I have git init, and then I have this git init, and I have my master branch. I don't have anything right now here, so I will make a file that is called touch. I don't know. I will use main PI, for example. So here I will use this file, and then I will edit the file, or well, I won't edit that. I will keep it empty because this is a very simple example. So now I have a Git that was initialized, and I have one a file here in master branch. So everything will be forked from master branch. So at this moment I will make the first commit. So I will use git add and add all the files. I will use git commit and use this for the first commit, and then I will check the Git Neuro to see if this is working or not. So I will go to the node where that is placed. So let's go. I have this. Okay, so I have my first commit. Okay, I think this is correctly working. So then the next step is that after you created your repository with first commit, you will create the other branches. In this case, I will create a test branch, and I will create 2 feature branches. So in that case, I will create a branch that is called feature 1, fit 1. I will create a branch that is fit 2, and I will create a branch that is test. Okay, so let's check that I have all the branches I needed. Okay, I have these 4 branches, and I am in a master branch. So now what I am going to do is go to the feature 1 branch. So I will switch. So I am here. I will do the same here. I'm not sure if I am in that branch right now. So okay, I will go to the folder, the project folder. So yes, I am in the correct place. I will also go to the folder here. So okay, so I am in feature 1. So right now I will make this very simple. So I will generate a file here that is called also fit1.py. Okay, so I have that that feature. I think I will change it a little. I don't know exactly what to put, but let's put something that is simple. This print hello, and then we will go to let's say, okay, let's say I have this, so I will make the first commit of this feature 1. So I will do this git add git commit, and now I think I have that feature. Yes, I have that feature. And we have that feature, then we will continue. So right now I have that feature 1, and with that feature 1 I think I will okay, since I consider that this is complete, I will merge that to test. So I will move to test branch, then we will do git switch test. I am in branch test, and from this branch I will merge without a for no, then I will use git merge fit1 a poner no fast forward, then I will merge. Let's see. Okay, the merge was successful, and let's say that the test is performed here. I think that this could be better understood, not sure, but okay, no, I think that I will keep this way, it's simpler. So here we have the feature, then we merge it to test, then we will check then if the test is okay or not, but since this is a very simple example, I will make this with a failed test. So test is failed. Let's say the test is failed. Then, since the test is failed, I will have to update my feature 1 and then merge again to test. Okay, so then I will return to master, or no, I will go to feature 2. I am in feature 2, and from feature 2 I will create a file that is fit2.py, and we will put here word, let's say I will do this. Then I have those two, then I could add it, I could commit. Okay, then I have my feature 2, I have feature 2, I have feature 1, and I have the test branch. So this is the time, so since this is the last one, so this goes up. Also the colors change a lot in Git Neuro, but this is still a good representation of what is happening in my repository. So let's say that okay, my feature 2 is ready, so I will merge it to test. So I will switch to test. From test I will merge. Now we have merged feature 2 to test, as you can see, and let's say the test was successful in this case. Okay, so feature 2 is now ready to be deployed. So what we do now? Well, we cannot deploy from test to master because test has wrong code, that is feature 1, and has right code, that is feature 2. So what we do is very simple, we just merge feature 2 to master. So we go to master, and now we merge feature 2. So feature 2 was merged, and feature 1 is still being developed. As you can see, feature 2 has been forked. This is a fork that we do, that we merge first to test, and then we merge feature 2 to master. I don't want you to confuse this with a fork in Git, but what I want to say, because it's not the same, but what I want to say is that we merge these to two places. Feature 2 is merged to two places, to test and then to master. That is the main concept of using Git Feature Flow. Then, as you can see in this last merge, the only thing that is merged to master is feature 2, so it means that we have only working code in master. So finally, let's say that we make the corrections to feature 1, Now we are in feature 1. And since we made the corrections, we again merge it to test, and if it passes, we merge it to master. So let's say that feature 1 passes the test. So what we need to do now is to merge feature 1 to master. Okay, so now we have it. We have merged feature 2 was merged first to master, then we merge feature 1 to master. If we go to master, we will have both files. In master with ls, and as you can see, we have both files here. So that's it. That was a very simple example of how to use Git feature Git Feature Flow. So I hope you can use that in your projects, or consider that for organizing your team and your projects. Thank you very much for your attention, and see ya!